let's use this to talk about the acronym SOHCAHTOA. We saw in the last video that there's a relationship between the triangles in the larger and smaller circles, but it turns out we don't need to consider circles at all. If we imagine our two circles, our unit circle and our other circle of unknown radius, and we put some angle in the smaller circle, then we can create a right triangle within that smaller circle and a larger right triangle within the larger circle. But we don't actually need circles here. We can just have a smaller right triangle and a larger right triangle whose angles are the same. And so we can look at any right triangle. Instead of writing sine, let's write this again, instead of writing sine of alpha equals y over r, instead we can recognize that the hypotenuse of a right triangle can just be the radius of a really large circle. We don't actually need to see the circle here. And therefore, we can think of sine as the ratio of the leg opposite the triangle. This would be, opposite the angle. This would be the height y, divided by the hypotenuse. This would be the radius. This gives us a new formula that says sine of alpha equals opposite over hypotenuse. Similarly, if we know that cosine was defined as x over r, we know that the x-coordinate of this angle t is just the length of the adjacent side. And so we could write a new formula that says cosine of alpha equals adjacent divided by hypotenuse. There's one more for tangent. We know that we've defined tangent of some angle as y over x, but we know from our little drawing here that y is our opposite and x is our adjacent, meaning our new definition is that tangent alpha equals opposite over adjacent. Now this is a lot to memorize, and so we've created an acronym that says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, just like these three formulas say. I realize this can be a little confusing, so let's jump into an example. We have a right triangle here, we know it's a right triangle, we know that there's a 30-degree angle here, and we know that the side opposite the 30-degree angle has length 7. This problem is asking us to solve the right triangle, which means calculate the length of every unknown side and every unknown angle. Specifically, for a right triangle like this, the hypotenuse is the longest side, that's the unknown length c. The side opposite our known angle, that is this one, opposite. And the side adjacent to our angle, adjacent just means beside, is a. So when it says solve the right triangle, let's try and solve c first. In order to figure out the value of c, we know we're trying to find the hypotenuse of the right triangle. But we're not going to use the Pythagorean theorem. We're going to use trigonometry. Specifically, we know an angle, we know the opposite side of that angle, and we're trying to figure out the hypotenuse. We're looking for a trig function that has both opposite and hypotenuse in it, and that trig function is going to be sine. We know that sine of some angle, in this case sine of 30 degrees, is opposite over hypotenuse. We know that the opposite side has length 7, and we don't know the length of the hypotenuse. What we've done is set up an equation that we can use to solve for h. We can calculate the hypotenuse. This will take a couple steps. The first one is multiplying both sides by h. H times sine of 30 degrees equals 7. And then finally, dividing by sine of 30. H equals 7 divided by sine of 30 degrees. Now it turns out we know what sine of 30 degrees is. Sine of 30 degrees is 1/2, and therefore our hypotenuse has length 14. We can do a similar process to solve for the adjacent side. We'd be looking for a trig function that has opposite and adjacent in it, since we know both the opposite and adjacent sides. And it turns out that that is going to be tangent, since tangent is opposite over adjacent. Let's write that. Tangent of 30 degrees equals opposite over adjacent. That's going to be 7 divided by whatever a is. And in this case, we have to solve for a. Just like before, we can break it up into 2 steps. A times tangent 30 degrees equals 7. And therefore, a equals 7 divided by tangent of 30. Now, we can look up tangent of 30 degrees, or we can calculate it. But we can get that tangent of 30 degrees is root 3 over 3. And therefore a, doing a bit of math here, is, let's see, this is 21 over root 3, or 7 root 3. Lastly, we need to figure out our remaining angle. But since all 3 angles in a triangle add up to 180 degrees, this angle has to be 60 degrees. There are other ways we could have solved this, and we'll talk about those in class. Speaking of class time, we will be finding values of sine and cosine from a triangle. We will do a lot more practice solving right triangles, and we'll talk about how to solve various word problems that require us to use this SOHCAHTOA technique. See you then.